Yeah, no, we have that sound. Sit down. Sit down, sit down. Good afternoon, sit down, please.
True. Business. Absolutely each. Absolutely each confession.
Bhavesh is there. Ayushman, Anand is there. Vaishnavi. Gaurang is absent. Yeah. Roshita is here. Raj, Roni, Anish is there. What is the last thing that we have done? Just look into your notebooks. Yes, why are the stars twinkling? That we have finished. No, the last part of the human iris. Last thing we have done. No. The stars are twinkling, but the planets are not twinkling. Then we have completed. Okay, now we have to do the last part, which is the scattering of light. Tyndall effect, scattering of light. Yes. Okay, let's pay attention. So we have seen in the ninth standard. Roni, yeah. Is everybody ready with your notebook and all? So this is something that we have seen in our ninth standard. Suppose you are taking a true solution. Okay? And you are taking another container. Boys and girls, would you like to shift your places or shall I shift you? I'll put you all in each corner because once I start, I don't want any disturbance. Okay, I want everybody to pay attention. Are we okay? Or you want to shift on your own? You want to go and sit there wherever? Are we good? So we said that whenever we are having a beaker which contains a true solution, and I'm having another beaker which has got a colloidal solution. Remember in the ninth standard we have learnt about true solutions, suspensions, colloidal solutions. So what happens if we are passing a beam of light in a true solution, there's no scattering, it just comes out. But if you're talking about a colloidal solution, that means the particles are so small that it appears to be as a solution, but it is actually a heterogeneous, okay, mixture. So in this case, what happens is when you're passing a beam of light, this beam of light is actually lit up. Why does that happen? Because obviously we are talking about scattering of light which takes place when it falls on extremely fine particles. So whenever we are talking about the Earth is nothing but it is enveloped by means of the atmosphere. So when we say it is the atmosphere, obviously it is made up of different gases. So you have gases, different gases like oxygen, nitrogen, etc. In addition to this, what else do we have in the atmosphere? Apart from gases, there is something else. What do you think? Ozone is also a gas. Vacuum. It is not present in the atmosphere. Moisture. Water vapor is present. Dust particles are present. Okay, you will have smoke. All these are different type of particles which may be present. Along with gases, you will also have dust and you will also have water vapor in the form of water vapor. Okay, so this is all basically present in the atmosphere. So what happens is when light falls on any of these type of particles, it is getting scattered. That means it is moving in different directions. So for us to know, we have already seen that your visible region of light, this is nothing but white light. White light is made up of how many different colors? We have VIB, GY, OR. So our human eye is capable of seeing only these colors, even though there is much more electromagnetic radiation in both the directions. But our human eye is capable of seeing only these particular light. So what is happening is we are talking about a longer wavelength and shorter wavelength. The wavelength of violet is very, very small. Okay, but wavelength of R, that is the red, it is larger wavelength. That means each wave is large, wavelength is large. Whereas for violet, the wavelength is very small. Here what happens, frequency is very high, here frequency is less. Why I am showing you this diagram is constantly in your textbook. They talk in terms of larger wavelength and shorter wavelength. So which has a longer wavelength? It is R, that is red light, which has got a longer wavelength, whereas the violet has got a shorter wavelength. So now we are talking about different type of natural phenomena like sky. Why is it appearing to be blue? Right? So when white light is present on extremely small particles, this particular color, that is your indigos and blues, these are the ones which are getting scattered more. So predominantly you'll find that the sea is blue in color, you'll find that the
But
sky is
why
blue.
not violet?
Violet, no, it
It is the lower sea, so it should be scattering the most.
yes, that is what I'm saying.
That is why it should look.
You see, it is basically what is happening. There's no particular demarcation. Even if you look here between green and yellow, okay, there's no clear demarcation between the yellows and the greens. It's a shade which is which is getting merged one into the other. So basically, when we are talking about blues and while indigos, so it is more of the blues which are getting scattered by extremely small particles. So you will find predominantly blue color because this is getting scattered because of the wavelength which is extremely small. But at the same time, you will find that something else is also happening. What happens during sunset? What happens during sunrise? What happens to the color of the sky? I'm sure all of you have orange and reddish shades. So let's see what is happening in that particular case. Once again, we look at the diagram of the Earth and we know that this is the atmosphere. Okay. So for a person, let us say he's standing on the horizon. For us, we cannot make out the curvature of the Earth because it's so huge. So when you look at the horizon, what does it appear? It appears as if it's a straight line. So we say that this is our horizon. And we say that the sun, when it comes up from the horizon, it looks as if it is the sunrise. Of course, you should not be drawing it so close. We are talking about something that is very, very far. So let us say very far away, this is the sun. And for us, the person who is standing at the horizon, it appears that the sun has come when it is at the horizon. But actually what happens? Even though the sun has not yet reached the horizon, even though it is here, the person will be able to see the sunrise. And why does this happen? Once again, if you remember, this atmosphere is not of a uniform refractive index. The refractive index is less here, and the refractive index of the layers of air is more towards the earth. So what happens to the sunlight? There is a constant bending taking place from a rarer medium. It is going to a denser medium. So obviously it is bending towards the normal. So when light from sunlight is coming through various layers, you find that there is actually a bending taking place. It bends like this. Did you see that? So for a person who is standing at the horizon, he is able to see the sun even though it has not reached the actual horizon. So it takes about 2 minutes here. Similarly, when the sun comes up here, and let us say it is setting down on the other side, the sun is not moving. Remember that it only appears to, okay, it appears as if it is rising in the east and it is setting down in the west. But actually what is happening is the rotation of the earth itself we have also. Similarly, what is happening when it is setting down? It appears as if the sun has gone down. This is the horizon. Okay? So we feel that the sun has gone down. Even though the sun has actually gone down, you will find that there is still some light on the horizon for 2 more minutes. So basically, for 2 more minutes, you will have the sunlight which is lit in the sky. So actually, what is happening? Your daylight has increased by 4 minutes. 2 plus 2. Did you understand? The actual sunset is taking place, but in addition to this actual sunset, 2 more minutes, and here you have 2 more minutes, so you will have an additional of 4 more minutes. Did you understand? So this is one of the questions that is usually going to be asked. Why is it that we say that our daylight has increased by 4 minutes? So you have to reason out and say apparent position of the sun and the actual position of the sun. And why does it appear as if the sunrise has actually taken place? It is obviously because of atmospheric refraction. Always use this word, atmospheric refraction taking place. And why does it take place? It's because the layers of the atmosphere around the earth is not constant. It is more denser towards the surface of the earth and it is less dense away from the surface of the earth. Therefore, there's a bending taking place. Is that okay? All of you see this? Advanced sunrise and sunset. Did you see that? The last paragraph here. Did you read? Read it. Advanced.
Advanced sunrise and immediate sunset. The sun is visible to us about 2 minutes before the actual sunrise. About 2 minutes after the actual sunset, because of atmospheric refraction, by actual sunrise, we mean the actual crossing of the horizon by the sun. Figure 10.1 shows the actual and apparent positions
Underline
of
these two words. Actual position and apparent position.
of the sun with respect to the horizon. The time difference between actual sunset and the apparent sunset is about 2 minutes. The apparent flattering of the sun's face at sunrise and sunset is also due to the same phenomenon.
Okay. Put a Q there. Put a question. Such a type of a question will come. And when we talk about this atmospheric refraction, remember to pick up the point from the previous paragraph. Students, do you understand what I'm saying? What is the point that you're going to talk about atmospheric refraction? That the layers of air is not constant. Okay? It is more dense towards the earth as when compared to the layers of the earth away from here. Now that is given in your first paragraph here. Correct? So you have to pick up those points and write it down here. Is that okay? Next is we are talking about, I told you regarding the scattering of light, the filtering effect, etc. Now we will see something more about why it is. We are talking about why the sky, we have already seen what happens and why it is blue light. Blue light is actually getting scattered by means of very, very fine particles. But sometimes what happens is during sunrise or sunset, you find that it is reddish in color. Okay? So if you look at this picture once again, we are talking about it appears to be orange or red. So what about the color? What about the wavelength? The wavelength of either orange or red is much more as when compared to the blues. Okay. So what is it? Why is it happening there? So let us see once again with reference to the picture here. This of course is once again your atmosphere. Constantly we are talking about atmospheric reflection. So even this phenomenon is because of atmospheric reflection. Okay? So what is happening here? Let's say the sun is right above you. Look at the sun rays. This is the atmosphere. This is the distance. Correct? So how is it at noon, in the afternoon? You don't find reddish or any other color. It's nice, light, bright blue in color. But if at all we are talking about the sunrise, what's happening? It's because of the atmospheric refraction. We find that the sunrise has to travel for a longer distance. Did you see the distance? Okay, did you notice the distance for the sunlight to travel through the atmosphere is much more as when compared to that of the moon. Okay? And that's the reason why it happens is it is getting scattered by some of the particles, like we said about the dust particles or the water droplets, which are slightly more as when compared to that of the gases. So if you see that the red light is the one which is getting scattered more. Have you followed? So what happens basically is during sunrise or sunset, we find that the sun rays has to travel a longer path as when compared to the moon. And that's the reason the red lights or the oranges, which have got a longer wavelength, that gets scattered more because of the particles. Okay. So of course the numbers have not been given here. The wavelength of blue is around 400 nanometer and the wavelength of red is around 700 nanometer. So if you look at 400 nanometer and this is about 700 nanometer, okay, it's almost about almost double, isn't it? If it was 800, you make out that it is double. Okay, so this is about 1.8 times the wavelength of the red light, of the blue light. Okay, and that is the reason why the red light is getting scattered. Another reason you will also see is if you are talking about red or the orange, okay, you have probably seen this adventure sports. Yeah, people who go for rafting, river rafting and all. You need to wear some jackets, isn't it? Safety jacket. What is the color? Yeah, life jacket. What is the color of the safety jacket or life jacket? Orange. Did you see that? Why is it green? Why is it not green or blue? So there's a particular reason. Because our eyes can see the red light, it does not get scattered. Okay, so suppose he needs to be rescued or something of that sort. It's easy for us to see the red light. Similarly, when we see the traffic light, what are the three colors? The first thing that you see is red color. So red color basically tells us it's danger or you're expected to stop or something. So it's red and orange, even anything. For example, even the persons who are working on the road, have you seen construction workers? Yes, they are giving
That is luminous also.
also luminous because obviously when light falls, when the traffic light falls on them, that actually gets lit up and obviously to avoid accidents. So that's the reason why we are talking about life jackets which are made of either red or orange color. Are we okay with that? Yes, okay, we'll be scattering of light.
Scattering of light. The interplay of light with objects around us gives rise to several spectacular phenomena in nature. The blue color of the sky, color of water in deep sea, the reddening of the sun at sunrise and the sunset are some of the wonderful phenomena we are familiar with. In the
Raj, look at your textbook. Okay.
in the previous class, we have learned about the scattering of light by colloidal particles.
Underline this word, colloidal. Colloidal particles are extremely small particles which is not visible to our human eye.
The path of a beam of light passing through a true solution is not visible.
Underline the path of light passing through a true solution is not visible. For example, if you are taking a beaker which contains salt water, glucose water, sugar water, that's not a true solution. So the path of light is not visible. Continue.
However, its path becomes visible through a colloidal solution where the size of the particles is relatively larger.
Underline this case. Colloidal particles are slightly larger than that of a true solution. Is that okay? Continue.
Tyndall effect. The Earth's atmosphere.
You remember Tyndall effect, 9th standard? Yaad hai na? At least the word yaad hai. Where did we find Tyndall effect?
Scattering of light.
Scattering of light.
Suppose you go to a very thick forest, you may find a beam of light coming. Or probably when you are seeing, if it's a dark room, you can find a small beam of light. Correct. Tyndall effect.
The Earth's atmosphere is a heterogeneous mixture
So
with minute particles.
What did I say? No talking in between now. Pay attention. Look at the book.
These particles include smoke, tiny water droplets, suspended particles of dust, and molecules of air.
Underline. What does an atmosphere consist of? Dust particles, water molecules. Okay. Air molecules.
When a beam of light strikes such fine particles, the path of the beam becomes visible. The light reaches us after being reflected diffusely by these particles. The phenomenon of scattering of light by the colloidal particles gives rise to Tyndall effect, which you have studied in class 9.
Underline this. Phenomena of scattering of light by colloidal particles gives rise to Tyndall effect.
This phenomena is seen when a fine beam of sunlight enters a smoke-filled room through a small hole. Thus, scattering of light makes the particles visible. Tyndall effect can also be observed when sunlight passes through a canopy of a dense forest. Here, tiny water droplets in the mist scatter light. The color of the scattered light depends on the size of the scattering particle.
Underline this. So what is the color? Which color is getting scattered? What does it depend upon? It depends upon the size of these particles. Okay? I'm slow talking now. I don't want any comments.
Very fine particles scatter mainly through light, while particles of larger size scatter light of longer wavelength.
Which is the longer wavelength? Yeah, red, orange. Okay, so that is the other side of the spectrum. Have you made a note of it? Larger wavelength, it is red and orange. Smaller wavelength, it is the blues and the violets. Okay.
If the size of the scattering particles is large enough, then the scattered light may even appear white.
Did you follow all that? Okay, till here we are speaking of Tyndall effect as well as the colloidal particles. So what are the colloidal particles? These are not suspended. Is it a heterogeneous mixture or is it a homogeneous mixture? It's a heterogeneous mixture. Because the amount of dust particles, the amount of water vapor is not constant all over the world. It is a heterogeneous mixture. Underline that. Atmosphere is a heterogeneous mixture. Underline the word heterogeneous. Why? Because it consists of all these particles and the percentage is not constant. So therefore, it is a heterogeneous. First paragraph. Okay. This one, Anish, you read? Anish, read. Not good. You read. By the color of the sky is blue. Last paragraph.
When the sky would have looked dark, the molecules of air and other fine particles in the atmosphere are size smaller than the wavelength of visible light. These are more effective in scattering light of shorter wavelengths at the blue end than light of longer wavelengths.
Okay, wait 1 minute. Is everyone ready? Because this is a very important statement. I want everybody to underline it. Okay? These are more effective. That is what? Particles of a smaller size are more effective in scattering light of a shorter wavelength. Okay, at the blue end rather than light of the longer wavelength, which is the rays. Okay, continue.
The red light has a wavelength about 1.8 times greater than blue light.
Did you understand why it is more? By a factor of 1.8. I've given you the numbers also. This is 400 nanometer, that's 700 nanometer. So it is 1.8 times the wavelength of the blue light.
Thus, when sunlight passes through the atmosphere, the fine particles in air scatter the blue color, shorter wavelengths, more strongly than red. The scattered blue light enters our eyes. If the Earth had no atmosphere, there would not have been any scattering. Then the sky would have looked dark. The sky appears dark to passengers flying at very high altitudes, as scattering is not prominent at such heights.
Okay, we stop here. 1 minute. Did you imagine what is happening? For example, here, of course, as long as there is atmosphere, we are able to see the different colors. But what happens to space? Space, obviously, there is no atmosphere. There is no scattering of light which is taking place. So, for any person who is flying at a very high altitude, the entire earth looks, or it appears to be dark because there's no scattering taking place, isn't it? Obviously, because there's no atmosphere at all. Okay, continue. You might have observed.
Last question. I observed that danger signal lights are red in color. Do you know why the red is least scattered by fog or smoke?
Underline. Why do we use red as a danger signal? Okay, put a question mark. Q there. Because obviously red light is least scattered by fog or smoke.
Therefore, it can be seen in the same color at a distance.
Okay. Is that okay?
What you have
Yeah.
what you have done, the ability of the eye to focus
So
on
that gives you a synopsis of this.
That's okay.
1 minute, 1 minute. Go there, go there. Okay. Okay. Who wants to come? Ayush? And then get up with your book. You're not doing me any favor by sitting here and chatting, right? Raj, move that side. Right there. You come here. Come here. Okay. All of you please take them. What is the last thing that I'm giving you? About starlight. Was it starlight? Rainbow, raindrop, I have finished.
the planets.
Planets are not twinkling and starlight. Starlight.
Why
is
do
good.
stars?
Okay. Yes. Come on, Dave, take down this question. These are some of the questions which is given just behind the text itself. Okay. The last question, question number 12.
Why?
Take down. Why does the sky appear dark? Why does the sky appear dark instead of blue? To an astronaut. To an astronaut. Question number 12. Ayush, what will be the answer? What points did you add?
Does not scatter.
You're talking to me.
Yes, the light does not scatter due to them going at a very high speed.
Speed,
Higher.
height.
Yes.
What else will you write? Look at the question. They're asking you two things. Why it does not appear to be blue. So you have to write about blue. Why it appears to be blue and why it is not appearing to be blue. Would you like to add on?
Because the stage doesn't have any atmosphere.
Exactly. Yes.
That is scattering of light is not possible.
Does not take place.
We can write about distance.
This not necessary. Basically, we say scattering of light is taking place only if there is atmosphere. And atmosphere consists of all these. Okay. Since there's no atmosphere in space, there's no scattering of light. Is that okay? Point number 1. Right now. Scattering of light is due to atmospheric refraction. Is due to atmospheric refraction. No, what I'm sorry. What did I say?
Reaction.
What did I say?
It's scattering of light.
Scattering of light is due to the molecules of air and other fine particles in the atmosphere.
Of air and
Other fine particles in the atmosphere that have size smaller than the wavelength of visible light. I repeat, see if you have written it correctly.
Wavelength of visible light.
Raj, you read and tell me. Read, what have you written?
Scattering of light is due to the molecules of air and other fluid particles in the atmosphere that are size smaller than the wavelength of visible light.
Yes, very good. Come on, write down. Next point. Very fine particles scatter mainly blue light. Okay, so that answers the first part of the question. Talking about why it is appearing to be blue. Now the second part of the question is asking, why does the sky appear to be dark for an astronaut or somebody who's flying in space? So what will you write for the second half?
Because of the lack of atmosphere.
Atmosphere in space. Okay, in space there is no atmosphere. Hence scattering does not take place. Come on. In space there is no atmosphere. Hence there is no scattering of light. The last point. Hence, the sky appears to be dark to passengers, same thing as what is given in the question. Hence, the sky appears to be dark to the passengers,
To the astronauts.
astronauts. Astronauts also is perfectly alright. Flying at very high altitudes. Take down another question. Danger signal lights are red in color. That's a question.
Give reason.
Yeah, give reason. Danger signal lights are
Red in color.
red in color. Give reason.
Let us see scattered by flowers of in the same color and distance.
And talk about the wavelength of red.
Very
Yeah. So first point you will write the wavelength of red light. How much is it? How much?
1.8
Times of that of what?
Blue.
Of the blue. Correct, very good. Right. The wavelength of red light is almost about or more than 1.8 times the wavelength of
blue.
blue light. Next point you will write. Red is least scattered by fog or smoke.
Red is
Least scattered by fog or smoke. Last point you will write. Hence, it can be seen in the same color at a distance. That's a sentence which is written here in the textbook. There's no need for you to write down that sentence. You can write, therefore, the danger signals are usually red in
It can
color
be seen in the same color.
In the same color.
It
at a
is
distance. Okay, or you can also write the danger signals are usually red or orange in color. Is that okay? Here? Okay. Next one. What will be the question about advanced sunlight and delayed sunset?
During summers.
By how much? How much is the daylight?
Five
Is
minutes.
it
2 minutes.
2 plus 2?
Four.
4. Isn't it? Come on, write on the question. What happens due to? It's not there. Come on, write down. What happens due to advanced sunrise and delayed sunset? Basically, the points which are given in your textbook are pretty good. So you can write down the first sentence from there. The sun is visible. What is it taking place due to? Why is this phenomena happening?
Atmospheric
Refraction. Most important is you have to mention. This phenomena is due to atmospheric refraction. You can start the statement by saying that. Start your answer. This phenomena is due to atmospheric refraction. Which book are you writing in? It's not this. Okay, second point. The sun is visible to us. Shh. Raj, your book. The sun is visible to us. Right? About 2 minutes before the actual sunrise.
Visible to us.
About 2 minutes before the actual sunrise. And about 2 minutes after the actual sunset. Next point. By actual sunrise, it means the actual crossing of the horizon.
Actual sunrise.
It means the actual, it means, or we mean. If we say it is we mean, it will be mean. It means, it will be means. The actual crossing of the horizon. Actual crossing of the horizon by the sun. Next point. Due to atmospheric refraction.
Ma'am, but they wrote now this phenomenon is due to atmospheric.
So what is happening due to atmospheric refraction? वो तो लिखो ना.
Bending of
4
light.
minutes.
That has to write. But due to atmospheric refraction, the sunlight bends and therefore the apparent position of the sun is higher than the actual position. What is apparent position? It appears to be higher. Okay.
Is higher.
Is higher than the actual position of the sun. This time difference is about 2 minutes. This time difference is about 2 minutes. Similarly, it is for the sunset. Did you write down? It is also for sunset. Similarly, it is also for sunset. And therefore, how much? You get an addition of 4 minutes of sunset. Is that okay? Clear? Look at question number 8. Have we written it? Why is the normal eye not able to see clearly? The object is closer than 25 centimeters. Have we written the answers? I think we have.
Yes, ma'am.
Just have a look at your notebook. Question number 8. Where do you go now? You sit down. You had that 5 minutes, right?
Yes.
In between you had. Dikha. Okay, fine. So what did you write? If you keep it closer to 25 centimeter, what happens? Your clearly. Yeah, tell me.
I get a little bit clearer and you cannot see it properly.
But what is this distance called? 25 centimeters is called what?
Focus.
Minimum distance. Isn't it? It's a minimum distance of clear vision. So your eye lens cannot focus anything less than 25 centimeters. Power of accommodation, when you get it more than this 25 or getting it less closer and closer to the eye, eyes will not be able to see it better. Okay, fine, this is okay, fine. Then, yeah, do this question number 5. All of you see question number 5. Person needs a lens of power.
Minus 5.5.
Yes. Have we done? Dekho. I don't think we have done it. No, we have not done it. Good question number 5. So what's given to us here? The lens of power, minus 5.5 diopter for correcting distance vision. Okay. Now, I've given the information on the board for those of you who don't have the textbook. What is the focal length of the lens required for correcting distant vision and your vision?
1 by minus 5.
So for both of them, they are given.
P is equal to 1.5 and then we translate.
Yeah, correct. So your formula for both the cases, P is equal to 1 upon F, and F is going to be in meters. Remember that. Okay. So continue from there. So what is it going to be? Focal length is equal to 1 upon P. Okay. Remember this focal length is in meter. Okay, it's given in meter. Your power 5.5 D, you will get your focal length in meters. So your answer, you can give it in meters, you can also give it in centimeter. Come on, do it. So for the first one, F is equal to 1 upon, there's a negative there.
Minus.
Yes. If it is minus, what does it tell? Is it convex lens or is it a concave lens?
Concave.
Concave. Because they have already given you that it is for distant vision. Distant vision is what? Myopic case. So myopia is always corrected by using a concave. And focal length of a concave lens is negative. Do this value and then.
0.
Yeah. If you are doing it in meters, you will get it as point something. But if you want to convert it into centimeters, it's much easier. So you can also do F is equal to times 100 divided by 5.5. This will be of course a negative. Okay, and this is going to be negative. This is going to be negative.
0.1.
Shift the decimal. Did you understand what I am saying? This is 5.5, right? If you want to shift the decimal, times 10 times 10. So it will be 1000 divided by 55. Come on, do that. How much is it?
So minus 0.18 meters.
0.18
meters.
Okay. Meters, you convert it into centimeters into 100.
Which is
80 point.
80
80 point something. Do that. Everybody come on, do it. 1.8 and then what is the other number after that? Give me to the second decimal place.
1.81.
So how much will that be? That is going to be 1000 divided by 55. Do this.
1.8.
1 point. Second.
Minus
1.8.
1.
1.8.
Yeah, correct. You can give it to me in centimeters. This is in meters. Okay, so times 100 if you do, you will get it in centimeters.
1 minus 1.
So that will be 18 point something.
That's yes.
We have to convert it to centimeters.
Not necessary, it all depends upon the answer, question. Sometimes they don't ask you, then you don't have to do anything. Because listen, but suppose it specifically asks you focally, express the focal length in centimeter, you must remember that this answer that you get will be in meters. So if you're asking in centimeters, then you have to multiply by 100. Otherwise, it's not necessary. So what is the answer there? 0.1
minus 0.1.
Yes, negative. So what is this negative sign tell us? What type of lens are we using? Make a note of it, please. Therefore, for treating or for correcting distant vision, concave lens is used. Now tell me what type of lens is this? We are using both concave and convex. So what is it called? Old people will require. Why is it called? Hyper भी है and hypo भी है. Myopia भी है. What is it called? It's a bifocal lens. What is it called? It's called bifocal because both are there. Yes, it is because of presbyopia. The correction is because of bifocal lens. Come on, do it for this second thing. For this one, P is equal to 1.5D. Find out F there.
50.
So in the second case, same thing. P is equal to 1 upon F. Okay.
0.67.
0.6. 6.
Money? 6, 7 is 6 will carry.
6. No.
6, 7.
So,
No, where is your
1862. 666.
Ma'am, it's a
It is
continuous
6 bar. No, yes.
666.
Yeah, 6 bar if I'm not mistaken. It is 6.6.
This,
Okay.
so,
0.66.
6 now. The second.
So here, you will get it as
0.667.
so you can write it as 0.67. You can write, yes, that's perfectly right. Now what is the unit here? What is the unit? Very good. It's in meter. Now suppose I want your answer to be in centimeter, what will I do? Yes, so how much will it be? It is about 67 centimeters. Is that okay? Have you all written it down? Okay. Can I just borrow your book, please? You have this question here. This is over, right? far point is 80 centimeters. Have we done that? Yeah, which semester?
6.
Okay. Girls, pay attention. Now we are in question number 6. Okay. Question number 6. The far point of a myopic person is 80 centimeters. Now I want you to remember what is happening. Far point, near point. What happens in a normal eye? What is the far point for a normal eye? Infinity, very good. Okay, but a person is myopic, so the far point has shifted. Now it is how much? It is 80 in front of the eye. What is the nature and the power of the lens required to correct the problem? Come on, write it down. What is the information which is given? First thing is, he is suffering from myopia. So write down the first point. Person is suffering from myopia. Object distance is infinity. Okay, and it is going to be corrected by means of a concave lens, right? So object distance is infinity. And the image what? Image distance. But where is it? He is able to see what is the number which they have given? It is 80 centimeters. And remember, it is going to be negative. It is going to be negative because the image is also on the same side. Right.
How many meters will be 0.8?
What is the lens formula?
Minus.
Yes.
1 by
1 by V?
Minus 1 by E is equal to 1 by E.
Yes. Substitute the values now. Object distance U and this is V.
Minus
0. 1 upon infinity 0. Okay. So this is also image distance V is also negative. So this is going to be 1 upon negative 80.
And 1 by U is 0.
Yes, that is 0. Is equal to 1 upon F. Therefore, how much is F? F is equal to negative 80 centimeters. Okay. Now have you finished or
1.1.
what is it that they are asking? What is the power?
Minus 1.
Yes. Now we have to find out the power which is equal to 1 upon F. P is how much? 1 upon 80. Is it going to be 80 or something else?
0.0.
Yeah, because now you have to convert it into meters. You understand? So it is going to be times 100 you can do that. So it is 10 upon 8. This is 80 divided by 100. No, so 100 goes on the top. Yeah, I have written as minus. So how much is the answer?
1.25.
So basically it is nothing but 100 divided by 80. So that is 5 by 4. 5 by 4 is how much? 1.25. And what will it be? Negative or positive? There's a negative sign here. Don't forget. So it's going to be negative 1.25. What is the unit? Power. Yeah, diopter, capital D. Okay, so the power is negative 1.25 D. So your closing statement is going to be concluding statement. Yes. Myopic eye. Come on, please write down. The myopic eye is corrected by using a concave lens. Therefore, your P is negative. Are you writing it down? Finished?
Myopic.
Hurry. Is corrected by using a concave lens.
Okay.
Yeah. There's another one similar thing. What is it? Question number 7. Look at question number 7. But now we are talking about hypermetropia. So it's exactly going to be the opposite. Same thing that you are doing. Is that okay? That is already given there. All the best, do well. We will basically we have concluded with the physics portion of teaching, not learning. Did you understand the difference between teaching and learning? Yeah, now constant revision, constant test. Okay? And I'll see you after some more time. Right? Whenever the revisions are starting, once again I'll be seeing you. Is that okay?
How much gap is there?
Revision later on. A little later on, not right now. So whenever you are having your, because this year you have constantly, every week you have a test. Like so, right?
Yes.
Two tests. Only one year.
No, sorry. Ma'am, there's one correction in the paper. MCQ, like radio consumption reasoning.
Yeah, okay.
Ma'am, it was something.
First paper you do, no? Light paper.
Uh,
I'll just.
It was something like if we keep a concave lens in water, the focal length increases.
Changes.
So that was the answer to that assertion is wrong and the reason is correct. It was that the focal length is independent. So, but the answer was assertion is true, but reason is false. In the
The option was it does not change.
Yeah.
Focal length does
So
not
we
change.
didn't get the marks for that.
That's correct.
And even for the first one, the ray diagram.
What is sophisticated?
Yeah,
Go beta, go.
Thank you.
Bye, bye.
Thank you.
Do well, huh? All of you study properly. Yeah.
Thank you.
Bye. Fancy that.
The second MCQ, second question, and the first one.
भैया पहले देख लो किसी ने कुछ लिखा है नहीं लिखा है
खाना कमी में बहुत कमी है
पूछा कि नहीं वो किसने लिखा है
तो इतना कुछ यार ये सच्ची में नाम
ये देखो यहाँ पे भी कुछ साइड बोल रहे थे मिलते से उनको अभी तक देते क्यों